All right, so here we have two numbers being multiplied, and we're just going to do our estimation again just to get comfortable, because some of these problems, the estimation will help you dearly. Like, it'll be like you work out the actual problem, you get a number, it looks good, and then if you estimate it, you're like, whoa, that can't be it, what happened? And then you can figure it out a lot better. So here with my estimation, what would 3 round 2? Yeah, so 3 is just 3. What's negative 1 and 1/10 round 2? Gracie?
Negative 1.
Thank you, negative 1. And then what's 3 times negative 1? Negative 3.
No, you wouldn't add them, you would divide them.
Yeah, because we're multiplying these two together. So we're just multiplying. So different from what we did last couple days. All right, and then multiplying them out. Here's a little, you need to know this because some of you get scared of decimals. And yeah, they get scared because you put this little sign right here when this could have been 3 times 11. Easy problem. You get 3 times 1.1. So usually you put the digit or the number with the most digits on top and the one with the fewer digits. Did I line up my decimal points?
No.
Does it matter when I multiply decimals? No, I don't have to line up anything when I'm multiplying decimals. So I get my 33, and then where does my decimal point go? Okay.
One decimal place to the right.
Yeah, you go from the far right, you go 1 to the left. It should go right here. Positive or negative?
Negative.
Because what's a positive times a negative?
Negative.
Does this fit?
Yes.
How far is it? Finn, how far is it from the estimate?
3/10.
Yeah, there you go. 3/10. 3/10. And it's positive. It's positive. All right, next one. Another decimal problem. I want you guys to try this one on your own. See if you can do it on your own. Cam? If you need to go. Yeah. Okay. So here I have two numbers being multiplied. Do they have the same signs or do they have different signs? Same signs. Automatically the product is positive. So this is what I even do on these problems. I know my answer is positive, so I don't even think about the signs anymore. I'm just going to multiply the numbers. And yeah, you guys multiply them out. And do you have to line up the decimal places?
Yes.
Okay, listen to the question. Do you have to line up the decimal places? No. Do they sometimes line up? Yes. It happens. Great. If it doesn't, great. You deal with the decimal points at the end. All right. What'd you guys get for 13 and 7/10 times 9 and 2/10? Justin? Okay. Close. I think you have your digits right.
125.91.
Very, very close. Super close. There's one little part, I think, with the addition. Thomas?
I'm not good. 1 is 6.4.
Ooh, we're getting closer. The digits, see, if you mix the two answers, you get the best of both. Paul?
126.04.
126.04 is the answer. Positive or negative?
Positive.
Positive.
I just got it.
Okay, now, is my estimate accurate? Well, let's do that real quick here. What would negative 13 and 7/10 round to? Ooh. Negative 14. Negative 14. And what would negative 9 and 2/10 round to? Ellie? Ellie. Negative 9. All right. It's still negative times the negative, so we know it's positive. This would give me what? It'd give me 126, which means how far am I from my actual? 4 hundredths. So you got a big pizza. You cut it into 100 slices. 4 of those slices would be how far you are from the actual. Is that pretty close? Yeah. Very close. And notice the signs are the same, so that works out. All right, I need some help. Oh, I'll go back. Okay, I'm going to need some help on this one. On the bottom of page 19, I want you guys to do number 2. I'm going to put it up on the board, and I'm going to pick on people who haven't come up yet. So if you haven't come up at all on the board to work out, you're going to be...
Number 2.
Yeah, number 2 on the very bottom, it says try these. Number 2, find the product. And let's see. Raise your hand if you've already gone. You've already been up here. And if not, it's okay. Swivel's kind. He's not judgmental. He just sits there quietly watching, letting me do all the talking. All right, sorry. All right, I think I saw most people. So I'm going to have someone do the estimate. So if you haven't come up, do you want to volunteer to estimate? You haven't come up yet? Okay, Chloe, you're going to do the estimate. And then somebody to do the actual who has not come up. Okay, Olivia here. All right, when you guys are ready, you can come up, you can work it out. But you're going to have to show me all the work up here for your estimate and for your actual. So round those numbers, and then tell me what are those rounded numbers going to give you. Yes, sir?
Are we also supposed to estimate?
Yeah, give me your estimate as well, and then give me your actual. And I'm going to come around and check those out.
I wanted to make sure that was right before.
Oh, this one? Yes.
I don't know how to do this.
No, just write what you did right under here somewhere. Just do that number equals whatever. And you can use either one.
Can we round it to the nearest half? Or just to the nearest whole number?
Oh, the estimate? Oh, round to nearest integer. So yeah, all the way to the integer so you don't have to make it too hard. So I'm here looking for some answers. And I'm not going to say good, correct or not. Look at it.
No, say it correctly.
Negative if it's a positive and negative.
Say that again.
Isn't the answer always a negative if it's a negative? Multiplying a positive or a positive. Okay.
Yeah. Okay, the estimate -5 and 15/100 does round to -5, and 2 and 4/10 does round to 2, and -5 times 2 is -10. So let's see how you guys do with your answer.
I think I did my math.
I think I got it right.
We'll find out soon. Okay, as I'm looking through the papers on your answer, like for your answers, some of you have the right numbers, but you don't have the right decimal place where it belongs. Some of you have the right numbers and the right decimal place.
Whoever said it was you.
Too loud. But you don't have the correct sign, so make sure we get that. All right, let's see. -12 and 36/100 is correct. But I have a question here. How does it relate to my estimate?
It's only off by -2.
Say that again, Finn. It's only off by,
-2
not negative, but just by 2 and almost a half.
and 3600.
So it would seem pretty significant, 2 and 36/100 off, but are they both negative? So that's a good sign. And then they're both double-digit numbers on the lower end of the teens, you would say. And then, do you know why that happened? Why is my estimate a little bit more far away from the actual? Do you guys know why? Yep.
Because 2.4 is close to a half.
Okay, so almost could have gone up to 3. Didn't we round both these numbers down?
Yes.
So didn't we make 5 and 15/100 down, 2 and 4/10 down? So that's why your number is a little bit lower.
Wait, I thought
Yes, Will?
there's like math quizzes that don't count. Are we never going to get those back?
Yes, you'll get them tomorrow. Tomorrow, I have the 8th graders I'm giving back today. You guys get it tomorrow.
We're not good at
No, you just have a lot more people to grade. Yep.
Is the NASH quiz on Friday
It's 1-6 to 1-10. And I'll write that up there to help you guys out. Okay, let's move on to a new one. Now we deal with fractions. Okay, a lot of people struggle with either decimals or fractions or just both of them. But I'm looking at this and I still want to go with my estimation. So I'm going to call on people and those people should give me an answer, not somebody else. So Will, what would 6/7 round to? To the nearest integer. 1. What would 4 1/3 round to, Ellie? 4 1/3 rounds to? 4. And 1 times 4 is 4. So that's my estimate. That's what I estimate it's going to be. So it should be close to that. Okay, when you're multiplying fractions and mixed numbers, or fractions and fractions, do you have to get a common denominator? No, that's only when you're adding or subtracting. So remember yesterday, did we have to get common denominators? Yeah. Today, do we have to get common denominators? No, because we are multiplying. All right, I'm going to keep 6/7 the same. And then I'm going to change 4 1/3 to, yes, sir?
13/3.
13/3 because we did the 3 times 4 plus 1. That's 13. Keep the same denominator. All right. A close cross-canceling or cancellation. Now, listen to me very carefully. Do you remember sometimes when you work out a problem, you work out a multiplication problem with fractions, and then you have to simplify it more and more and more? Have you done that before? If you cancel before multiplying, you don't have to take that final step because you've already done it. But you do it with smaller numbers. So here, you can cancel either one of these numerators with either one of these denominators if possible. So do you guys see any common factor numbers? Yes. 6 and 3, there's a numerator-denominator match, I should say. So I make it 2 and 1. So hopefully you know how to do that. Yeah, sit properly just in case. I've had people slip. Sorry. Okay. Is there anything else to cancel? Anything else left to cancel? Okay. So now we just multiply across. 2 times 13 is? 26. And 7 times 1? 7. And then how do I convert that back into a mixed number? Like how do I, that's a fraction, but I want it as a mixed number because it's improper. What do I do? Yes?
You divide 7 by 26, which is
3 and 5/7. So all I did is ask, how many times does 7 go into 26? It goes into it 3 times with the remainder of 5, and then 7 is the denominator. Positive or negative?
Positive.
All right, what do you guys think here? How far is it? Raise your hand. How far is it? Elijah, I see that hand.
2/7.
2/7 away. Okay, so you have a pizza, you cut it into 7 slices, 2 slices away from the actual. Yes, sir?
Miss Shuey told us you don't like NC Santy.
I don't like? Oh, I don't even know who that is. Like, other than from what you guys, sing. Yeah.
It's really good.
But it actually helped.
Yeah, so if it helps, use it. I'm all for that. But well, then I can't give you your homework.
Who cares? I'm
I mean, I'm going to give you the homework, but I can't give it to you early.
No.
All right, go ahead, work this out. I'm going to call. That's all right. I'm going to call 2 of you up here who haven't come before. Dylan, have you been up? Dylan, you'll come and do the estimate, and then have I had Daniel? Do you want to come and do the actual? Okay, work it out, guys. Get your numbers, and then when you're ready, you can come on up. Yes, ma'am?
I need help with the estimate.
Okay. Oh, yes, with the fractions. Okay. All right, so we'll look at it.
So if you told me to do like the line or whatever, so
Sorry, the what?
Like 5 and below or 4 and below.
Yeah, you could do that. That's when you're going to halves.
Oh, okay.
So here's even easier. Is 4 close to 5? Like, is this 4 close to the denominator? So you should be 1.
And then for this one, it's closer to 11.
Still be 1. Like, this would be close to 1.
So what if it wasn't?
You would go down to 0 on those.
Close to 1.
Yeah, so here's okay, I look at this one, and I'm like, all right, is it close, is 4 close to 5 or close to 0? Which one is it closer to? 5. It's closer to that denominator. It's not closer to 0, so 1 times negative 1. All right, 1 times negative 1 is negative 1, and so now we have the actual. Again, if you cancel out before you actually multiply across, makes your life easier, if possible. Sometimes it's not. That happens. Man. Did you do it right? Then it should be right. And then just circle it and you're good, Daniel. All right, let's see here with Daniel. He sets it up. Notice he doesn't even worry about the negative sign anymore, because what are two numbers with opposite signs going to get me when I multiply them? Negative. Automatically. So it's a negative, and that's reflected there. All right, is there anything to cancel out here? No. So you just multiply across. 4 times 9, 36. 5 times 11, 55. If you canceled out as much as you could at the beginning, this would be your final answer. You're done. Wait, what goes into 36 and 55? Well, nothing, because nothing went into the canceling at the beginning. So negative 36 55ths. Oh, but that's way too far from negative 1. How far? Close. Someone said it. 1955ths away. You cut a pizza, 55 slices, 19 of them. You're like, that's a lot. Exactly. So that's really not that much. Okay. How many of you feel good with just multiplying two numbers with the same sign, two numbers with opposite signs? Those rules are pretty straightforward. We are going to do something different. All right. Listen carefully. Listen carefully. This next part is an introduction for our year to what we call the distributive property. Okay? This is actually something that for a lot of students, especially at first, when they start working it out, they're like, no. Why? Go ahead and just copy this down, and I'm going to explain some things to you.
Is distributive property going to be on our homework?
Yes, you'll have 2 problems on this part. So not many. Or just what we just did, yes. And so I was asking the Lord, as I'm prepping up, I'm like, Lord, please give me the words to be able to explain this well, and please give them the wisdom to be able to take it well. Now, that doesn't mean we're not going to do it perfectly. Mr. A will stumble. You might stumble, but you will get it as time goes on because God is that good. Okay, so write that down, and let me tell you what I do with this. All right, distributive property, as much as students hate it, it's going to be a tool that you're going to have to use in Algebra 1. Like if you ask any 8th grader and ask, do you have to use a distributive property, they're going to say yes. Some are going to say yes, some are going to say yes. But they're going to say the same answer in different ways. Okay, in your case, you technically don't have to use it on the problems that you're going to be applying, even on this homework, but you will use it. And you will do your best to do it because you want to get practice or something you're going to have to do anyway. Now, for me, I'll just give you a little example. Mr. A, just growing up as a math student, struggled with mental math. How many of you struggle with mental math, like doing it in your head? I struggle. Because what happens is this. My mental math would be like this. So you tell me a problem, and I have a paper in my mind, and I'm writing the problem down. And I'm working, what was that number I wrote down? Wait, what? I just forget the numbers. I struggle with that. But just like with any other skill, mental math can be developed. Do you know why they do mental math drills? Because they want you to get better at it. Now, Mr. A still is not that great. But the distributive property helps me to do mental math much easier than I used to do it on my paper, which gets somehow, it's like disappearing ink. I write it, and then I'm working. Wait, where'd it go? This distributive property really helps me out with that. Okay, did anyone write this down? Everyone good with this? Okay, this is what's happening here, guys. This is the original problem that you're going to be getting, and you're either going to have 2 things being added inside of parentheses, or you're going to have 2 things being subtracted. Okay, so here you're either going to have an addition or a subtraction problem inside of parentheses, okay? But you're also going to have a number that is outside those parentheses. And what do you think is happening with A and B minus C, or A and B plus C? What operation is going on between A and these 2 guys? What operation? Multiplication, right? Multiplication. Now, order of operations says, what should you do first? What's inside the... So you're supposed to add B plus C first, then multiply by A. That's what you're supposed to do. Guys, I'm telling you right now in Algebra 1, you're going to get to that problem. You're going to say, all right, add B plus C. There's nothing I can do to add B. I can't add B plus C. They're not like terms. I can't combine them anymore. But can I do anything else to simplify it? And yes, it's a distributive property. So here's what you do. You're going to take that outside term, the one that's being multiplied outside, and you're going to multiply it by the first term inside. So a times b, that's right here. Do you see that? See where I got ab? That means a times b, by the way. And then the second thing you're going to do is you're going to multiply a and c. That's where I got this. And since these guys are being subtracted, guess what's happening between these two guys? They're being subtracted. Okay? These guys are being added, so what's happening between these two guys? They're also being added. Okay, I'm just walking through the general theory of it, and then we're actually going to do a couple problems, and then I'll let you go. Okay. And I'll do these arrows because that'll help people out.
So you would multiply a times
Yeah, a times b, and then I'm going to multiply a times c, and depending on what was happening, addition or subtraction, I'm going to add or subtract those.
It'll be A times C and then A minus.
A times b, and then a times c, and those are being subtracted down here, and those are being added up there. Okay. Yeah, and it's a little tougher because the numbers you use are a little bit harder. This is actually nice. Okay, let's look at a problem. All right, this is a problem you're going to get. Now, what do you already notice off the top of your head? You have numbers that are both decimals and... So, do you guys remember how to handle these in adding and subtracting? What do you do when you have both types of numbers? You can either make them all decimals or all fractions. So you choose. I would say in this problem, I'm going to make them all fractions because two of them are already fractions. I mean, I'm just going to do that. So what I'm going to do here is I'm going to rewrite this so I can make this right here a fraction. But it's not a fraction. Right now, it's kind of like a mixed number. So negative 4/5. What would negative 1 and 25/100ths be? It'd be 1 and 25 over 100, which is 1 and 1/4. So negative 1 and 1/4 plus 5/8. So this is not even distributive property, guys. This is just trying to get all the numbers in the same format. Okay, we're not even doing distributive property yet. Here, not yet. You'll see what's going to happen.
Simplify 1 and 25 over 100.
Yes, we did 25 over 100 is 1/4. Okay, and then I'm not going to deal with it as an mixed number, but as an improper fraction. So what is 1 and 1/4 as an improper fraction? 5/4. You guys agree with that? And actually, yeah, I'll put it here. Negative 4/5 times negative 5/4 plus 5/8. Okay. Do we have two things being added inside of parentheses?
Yes.
Mm-hmm. Do we have something multiplying both of those?
Yes.
Okay, so we're going to use or apply, we could say, the distributive property. So this is what I'm going to do, and I'll show the work. I'll underline things, and I'll show what I'm doing up here. I'm going to take this number, the A number. This is A, by the way. You remember how A was on the outside? This A number, and I'm going to multiply it by B. So I'm going to do negative 4/5 times negative 5/4. Sorry, don't give me what it is yet, but I'm just walking through. Yep.
This problem, would you have to use that?
No, you could
multiply the denominators, right? By like...
You could get common denominators, add them together, yeah, but I want you to use distributive property. And then later, Jack, and really for all of you, there's going to be a point where you can't add these together, so you have to use distributive, but we're just going to see how it works out here. All right, here's my work. Negative 4/5 times negative 5/4. Remember I said to multiply those? Okay, that's what I'm doing right here. I'm multiplying those two right here. What else am I going to multiply? Does anyone remember? I should multiply negative 4/5 by 5/8. I'm going to multiply negative 4/5 by 5/8. And I'm going to write that here. Negative 4/5 by 5/8.
Aren't the same signs positive always?
Well, yeah, I'm not getting into the actual multiplying. I'm just showing you I'm multiplying this times this, and then we'll use the rules we looked at today. All right, what was going on between these two numbers inside? Addition. So what's going on between these two products? Addition. So that's what I'm putting there. And trust me, that makes a difference. No pun intended. Okay, do you know how to multiply these two together? Do you know how to multiply those two together? Yeah, they're both negatives, so they're going to be what kind of answer? Positive. So I'm already done with the negative signs, And then is there anything I could do here? So I get here positive 1. That's very nice. Okay, and then here, let's go ahead and multiply that out after canceling, because I see there are things that cancel out. So okay, I had a negative times a positive, which gives me a negative. And then what's 1 times 1? 1. What's 1 times 2? 2. And what's going on between these two? They're just being added, right? So 1 plus negative 1/2. Yeah, negative 1/2. Okay, which would be what?
Negative 1/2.
Ooh. Positive 1/2. Now, listen. The temptation was to say negative 1/2, but here's why it can't be negative 1/2. Okay, are we adding two numbers with different signs?
Yes.
So what do we have to do? Same signs, subtract. See, remember we're thinking adding, not multiplying. Remember they're adding? All right, what's 1 minus half? Half. So which one has the greater absolute value?
The 1.
So it's positive. So we're going back to the addition rules. 1/2?
How did you get, I don't understand how you minus 1 from 1 half.
No, I subtracted 1/2 from 1. So I did 1 minus 1/2, which is really weird, but I can just make that 2 halves.
Okay.
Minus 1/2 is still 1/2. Okay. And some of you can do it in your head, some of it not. Okay. How many of you understand? I'm not saying you could do it on your own, but you're like, I guess I kind of followed what you were doing. Okay. Let's do it one more time, and then I'll let you go. All right. Last one here. Do we have two things, in this case being subtracted in parentheses, and then something outside multiplying both of them? Do we have that?
Yes.
So what property can apply? Distributive property. And that's what we're going to do. Mr. Ray, can you do it a different way? Of course. There are many ways, really cool, many ways to do this problem. We're just getting practice. So what I'm going to do is I'm going to make, what should I make all the numbers, by the way? Decimals or fractions?
Fraction.
I'm just going to keep them as fractions. So is it okay if I make this 3 over 1?
Yes.
And then I'm going to make this right here negative 43 over 6 minus 2/3. I just made everything improper, and that's going to make the multiplication real nice. Okay. Does anyone know what A is here from the distributive property? What's A? Finn? 3 over 1 is A. What's B in this problem? Ryder? Negative 43 over 6. What do we do with A and B? So I'm going to show that over here. 3 over 1 times negative 43 over 6. So I'm just multiplying those two together. That's A times B. Okay? Does anyone know what C is in this problem? What's C? 2/3 right here. So what do we do with A and C? We multiply those two together. So that's 3 over 1 times 2 over 3. What do we do with those two products? Those two multiplication problems, what do we do with those two products? We subtract them. We put a subtraction sign right here. If these two are being subtracted, those two products are being subtracted, and it was vice versa for the other problem. All right, here, before we multiply, can we do anything to make this easier? Yeah, we can cancel out the 3 and the 6. So what do we get here? Negative 43 over 2. That's where we get that first product. And then the second product, what can we do to figure that out? Oh, thank you, threes, for getting out of the way. What's this going to give me? Good, 2 over 1. And what's going on between these two? Yeah, subtraction. Yeah, so now that we're subtracting, you could do this a couple ways, but can you just subtract like they are? No, you need now a... You see how we're using multiplication rules and addition rules on the same problem? It is confusing. Just take it slowly, one step at a time. Ask yourself these questions. What is the common denominator?
2.
So I'm going to make this fraction right here. I'm going to multiply by 2 over 2. Make it 4 over 2. Now this is where it gets tricky. All right, do we have common denominators?
Yes.
Good. But I have to subtract the numerators, right? So I have to do this. This is the last step, but if you can handle it, you're good. It's negative 43 minus 4.
No, we add.
Okay, how do you rewrite it as an addition problem? Negative 43 plus negative 4. Do you guys remember stay, change, opposite?
So we're adding that too?
Yeah, we got to get that. Because you could subtract them, which gives you the same thing as what we get here. So what's negative 43, and it's going to have the same denominator. What's negative 43 plus negative 4? Over 2. And then can I change that to a mixed number?
Yeah.
Go ahead.
3.5.
Close. Close. I haven't heard it yet.
Negative 20.
Negative 23 and a half. Negative 23 and 1/2. Ooh, almost wrote the wrong thing. Negative. Now, guys, how many problems did I say you have to do this? 2. So you're doing majority of the other problems, but you will have some of these. Yes, sir.
For Algebra 1, how many problems like that do they have?
Honestly, Wilson, there'll be a time where every single homework will have at least one of these. Some of them will have all of these.
How many do they have?
Oh, they have they have 10 last night. They have 15. Some nights 20. This just depends.
Wait, this year all of them have?
No, Algebra 1. Algebra 1. You guys will get it a little bit. Okay, your homework tonight is numbers 2 to 34 even, and then 37 to 42 all. Uh-oh. Now, if you look at 37 to 42, it's a fill in the blank. You're like, what? Fill in the blank? All it wants you to do is tell them if you have two numbers that are positive being multiplied, your answer is going to be fill in the blank. You just put positive. That's all you have to put there. But that's for the last section. Goodbye, Swivel.